There we go. Okay. So that's the rate that we're given. And we're being asked how fast is the height of the shadow changing when the person is 8 feet from the wall. Okay, so that tells us the rate that we're solving for. And since the height of the shadow is represented with y, that means we are trying to find dy over dt at the moment in time that the person is 8 feet from the wall. So that's when the distance 20 minus x is equal to 8 feet. Which you could then determine what x is equal to at that moment in time, which would be the distance of the person from the spotlight. And you could do that just by subtracting 20 from each side, divide by -1. So x would be equal to 12 feet at that moment. Is everyone okay to hear? Or does anyone have any questions? Have I lost anyone completely? Okay. So we've stated the given rate. We've stated the rate that we're solving for and when. We need the relationship between the quantities that are changing. And that relationship has to have x's and y's in it, right? Because we have a dx over dt and we're trying to find dy over dt. So going back to the picture, notice that we have I can see two right triangles in this picture. So there's a right triangle that's created from here. There's a right triangle created here with the person in the spotlight. And then there's also a right triangle created from the shadow and the spotlight. These are both right triangles, and they are actually similar right triangles because this angle equals to this angle. And obviously they share that same angle there, and they both have right angles. So they are similar triangles, which means that the ratios of their sides are going to be equal to each other. So we could say that side y over 20, or the ratio y over 20, is equal to 6 over x. This is thinking about similar triangles. And that's the relationship that we can come up with between x and y. And if we wanted to kind of simplify that a bit to make it easier for when we want to differentiate, we can multiply by x on both sides, multiply by 20 on both sides. So like where we could have x times y equals 6 times 20 is what, 120? I don't know if that necessarily actually makes it. We're just going to have to use product rule. Okay, so we've stated the given rate. We've stated the rate we're trying to solve for. We have a relationship between the variables that are changing. We're ready to differentiate. So we're going to differentiate each side of this equation with respect to t. And On the left, because x, y is a product, we're going to use product rule. So first factor times the derivative of the second factor with respect to t would be dy over dt plus the second factor times the derivative of the first factor with respect to t would be dx over dt equals to 0. And after we find the derivative, we can look at the values that we can plug in. So dx over dt is 2.5. X is equal to 12. We're solving for dy over dt, but we're missing y still. And if you remember from the ladder example last time, when we were missing a value, we just used the equation or the relationship that we came up with between the variables to solve for that other value at that particular moment in time. So we can go back to that original equation, which is y over 20 equals, or you can use the x times y equals to 120. 6 over 12. Right, so then what? We get y equals to 10 feet. So then we can plug in that value for y. So plugging everything in and then solving for dy over dt. My calculator right here, so I'm going to use my notes. Oh, so that ends up being 12 times dy over dt, and need my notes, plus 25 equals 0. So dy over dt is negative 25 twelfths. And y is being measured in feet, time is being measured in seconds, so that's feet per second. So we can say that the height of the shadow is, because it's negative, it means that the height will be decreasing. At a rate of 25 twelfths feet per second. When the person is 8 feet from the wall. All right, does anyone have any questions?